This video is on the review of temperature. We will now use the ideas and concepts discussed in this chapter, temperature, to do past year questions. The first past year question we do is from October, November 2017, variant 43, question 1. In part A, we have to state what can be deduced from the difference in temperature of two objects. It is important to know the temperature difference between two objects because we know that heat energy will be transferred from a region of higher temperature to a region of lower temperature. The second important point is that the rate of thermal transfer increases if the temperature difference of the two objects becomes larger. In part 2, we have to state the basic principle by which temperature is measured. We use the thermometric property, that is a physical property of a substance that changes with temperature to measure temperature. In part B, by reference to your answer in A part 2, explain why two thermometers may not give the same temperature reading for an object. The reason is because the physical property used in the calibration of the thermometer may not change linearly with temperature. This means that equal increment in temperature may not produce the same change, equal change in the physical property of the thermometric property chosen for the thermometer. The two thermometers will show identical values only at the two fixed points used to calibrate the thermometers. The two fixed points usually used to calibrate the thermometers are the ice point at 0 degrees Celsius and the steam point at 100 degrees Celsius. In part C, we have a block of aluminium of mass 670 grams, which is heated at a constant rate of 95 watts for 6 minutes. The specific heat capacity of aluminium is 910 joule per kilogram per Kelvin. The initial temperature of the block is 24 degrees Celsius. In part 1, assuming no heat energy or thermal energy is lost to the surrounding, show that the final temperature of the block is around 80 degrees Celsius. The heat energy absorbed by the aluminium is supplied by the heat energy provided by the heater. The heat energy absorbed by aluminium is given by the formula mc times delta T, whereas the heat energy supplied by the heater is power times time in seconds. Therefore, your delta T equals to PT divided by mc. So equals to 95 times 6 times 60 divided by 670 times 0.91. This will give you 56.1 degrees Celsius. This means that the temperature of the aluminum block will change by 56.1 degrees Celsius. Now, since the initial temperature of the aluminum block is 24 degrees Celsius, the final temperature of the block will become 56.1 plus 24, which will give you an answer of 80.1 degrees Celsius.